Now let's perform a simple electromagnetic field simulation. First we build a stub filter with an open quarter wave transmission line. This is done with the schematic editor, because the results of the circuit simulation should be compared with the field simulation. We start with two source components that are the input and the output ports for the S parameters. The PCB properties are defined in the substrate component. Relative permittivity, the substrate height, and the metallization thickness are entered directly in the schematic. Now, the microstrip structure is built. Note that the transmission line components are placed in the same orientation, like they need to be in a real layout. This design will make the conversion into layout very easy. All components will now be connected by wires. Finally, the circuit simulation is set up with an S parameter component. Some component parameters needs to be changed. The microstrip width has to be adjusted to 50 ohms. As this must be done many times, it's more comfortable to use the change dialog. First, search all properties starting with W. Then change all of them to 0.4 millimeters. After everything is done, the schematic is saved. In the last step, the S parameter simulation is performed, and the results are displayed in a diagram. Now we come to the electromagnetic field simulation. A layout can be created from the schematic automatically. The orientation of the schematic components are already correct, therefore the layout need not be changed at all. As the result of the circuit simulation should not be overwritten, the dataset file name of the field simulation is changed. Now let's start the electromagnetic field simulation. Of course, the simulation takes quite a while. So we need to be patient, and wait, and wait, and wait, and wait even longer. When the simulation is finally done, the results can be displayed in the diagram. We choose the correct dataset and add the S parameters in decibel to the diagram's graphs. So at the end, we can compare the results of circuit simulation and electromagnetic field simulation. If we like the design, the layout can be exported into GDS file format, which is the standard format for the production of a PCB. Let's demonstrate a more complex example. An interdigital filter cannot be calculated with the circuit simulator because there's no model for multiple coupled lines. That's why we create a layout of the filter and perform an electromagnetic field simulation. The simulation domain is already quite complex, therefore the calculation takes several minutes. So I'm really not angry with you if you skip this part of the video. You are really allowed to do it. Okay, after a long time, the simulation has successfully ended. The result is amazing, isn't it?